Hello everyone, and welcome to Successfully Deploying 4K Digital Signage, presented by IBASE Corporation with Intel and Digital Signage Today. This is Christopher Hall. I'm the Director of the Interactive Customer Experience Association, and I'm going to be hosting today's webinar and moderating it. And I'm going to introduce our speakers here in just a second. But first, I did want to remind everyone to please stick around till the Q&A session at the end of today's presentation. During the Q&A session, you'll have the opportunity to submit questions to our panel and possibly have them answered live. I'll also be telling you how to connect with our panel after the presentation is completed, just in case we don't get to your question this afternoon. The 4K ecosystem continues to mature with the availability of 4K panels, ultra-high definition content, and signage players available in the digital signage market. With 4 times the resolution of traditional Full HD displays, Ultra HD 4K offers a massive improvement in image clarity that helps boost shoppers' attention and engagement. In order to meet the growing 4K requirements, digital signage player provider IBASE says that it has developed the first 6th generation Intel Core-based 4K signage player on the market that has 3 HDMI 2.0 support. In this webinar, IBASE and Intel will walk you through how to deploy 4K digital signage successfully, showcasing some of the numerous customer success stories deployed with these player solutions. Attendees today will learn the digital signage market trends within the 4K ecosystem, how to pick the right 4K signage hardware solutions for quick time to market, and how to deploy 4K digital signage successfully. All of which leads me to our panel today. Today we're going to hear from 2 experts with real-world experience in deploying 4K digital signage. First, we have with us Dwight Louie, the lead designer for IBASE's SI613 signage player. A 9-year veteran within the IBASE group, Dwight was Director of Product Development for North America and the lead designer for the SI613. And we also have with us Naren Kumar, the Segment Marketing Manager for Digital Signage North America for Intel. With 18 years of technology industry experience, Naren works with the digital signage ecosystem, including OEMs, ISVs, SIs, and distributors, to enable digital signage solutions driving rich, immersive, and personalized experiences. Now, before I do turn this over to today's speakers, I do want to mention that there is a full screen option for the slides on the upper right-hand corner of your screen, just in case any of the numbers or details in some of the slides are difficult to read at their normal size. And with all that out of the way, let's begin today by turning the podium over to Dwight. Dwight, good afternoon.
Good afternoon, and thank you. My name is Dwight Louie, and today I'll be talking about what 4K is, how to get 4K content out there via digital signage solutions, and what are the challenges and solutions that are available to help you do that. So to begin with, I know that most people probably already know this, but I think this helps put everything into perspective. What is 4K? Well, 4K is called 4K because it is about 4,000 pixels across. Now I say about because it's not exactly 4,000. Now the most common resolution that displays that call themselves 4K displays is 3840 by 2160. Now that is exactly 4 times the screen area of the classical HD 1080 display. 4 times. It's equivalent to 4 screens tiled together. Right? Now there's also 4K digital cinema. If you go to your favorite movie theater and they have 4K high definition digital cinema, that's actually 4096 by 2160. So a little bit of a difference in resolution there. Not particularly critical, but those are the 2 common resolutions that are commonly described as 4K. Now 4K is also sometimes referred to as 2160p. And the reason it's referred to as that is that it has 2,160 horizontal lines in the screen area. Now if you look at the slide, you'll notice how much more pixels and how much more definition and how much greater of a challenge 4K is compared to some of the other things that we are familiar with. This is 4 times, 4K is 4 times HD 1080. 4K is compared to 720p, which is what we still get a lot of our HD digital broadcasts in. much, much, much bigger. It's almost 9 times the screen area. And DVD, I mean, a lot of us still have DVDs, don't we? I mean, it was almost like yesterday when we moved to DVD from things like laser discs or VHS cassettes and things like that. And if you compare DVD quality to 4K and you look at that, that is almost unbelievable. It is, I don't know how many times, but it is a lot. It's almost, more than 25 times the resolution of DVD. So that's what 4K is, and it is what's hot in town today. And we're going to talk about what are the things that makes it so great and what makes it so difficult sometimes to say, I'm going to have additional signage in 4K. But we can solve those problems, and we'll talk about how we can do that today. So the challenges of driving 4K public displays, I prefer that term to digital signage because it really is a public display. It's not a sign. Now, 4K is exactly the same number of pixels as driving 4 HD 1080 screens at the same time, 4 independent 1080 screens at the same time. If you turn the clock back 2 years, 3 years, that was like almost unbelievable from a single player, right? But today we're talking about 4K, and one 4K screen is exactly that. It's exactly the same as driving 4 HD 1080 screens. Now, obviously, in order to do 4K, your display has to be of 4K resolution. There's no shortage of that today. It's very, very available. But the interface must also be able to support 4K. That cable that connects your display and and your player must be able to transmit that display information. 4K performance is great in the sense that it has great resolution, but it's only meaningful if you can render that picture, you can render that content smoothly, and in a manner that is attractive to whoever is looking at it. Now, obviously, finally, if your content is not 4K, but you're delivering it on a 4K screen through a 4K player, through a 4K connection, well, that doesn't do you any good, does it? So the next thing we're going to talk about is connections. These are the things that don't work. These interfaces, if you have any of these interfaces in mind, or if your infrastructure, contains, screens and players and whatnot that's connected by any one of these things, you can forget about it. You need something else. The old analog connections, like the VGA connector, the SVHS connector, component video, either doesn't support those resolutions, or even if they did, given that analog really it doesn't have a fixed resolution, even if they did, the quality would be abysmal and you wouldn't want it. Now DVI, good old DVI does not support 4K. DVI comes in 2 forms, single and dual link, and neither of those go to a high enough resolution. So that brings us to some of the interfaces that are more recent. Now we have HDMI. Now, every screen or projector or whatever it is that you have out there will have an HDMI connector. Okay, but all HDMI are not created equal. The older versions of HDMI, 1.0 to 1.3, does not support 4K resolutions, period. The newer versions, like 1.4, does go to that resolution, but only at 30 Hertz, at half the typical refresh rate of the screens, which can affect the smoothness of the content that you're rendering on that screen. Now, today I know that it is very attractive, to think about driving those displays without a cable. There's always, YD, Miracast, AirPlay, and all these, ways of connecting the screen to the player, which does not involve a cable. Sounds very good. At this point, if you're trying to deliver 4K content, they're not going to work very well. The reason they're not going to work very well is that most of these either do not support 4K wirelessly, or if they do, it requires that the video stream, the output, okay, after it being decoded from your content file being decoded, they have to be recompressed into a compressed form before it's sent out wirelessly, and then on the display end it is decompressed again. Now we are already stretching, pushing the limits of our hardware's capabilities in terms of rendering 4K content. Adding onto that, real-time compression will do horrendous things to your performance. And the final product that was delivered to your screen is compressed, so you're going to get artifacts and whatnot when there are a lot of transitions and things like that. So I definitely do not recommend even thinking about the wireless stuff until probably a significant amount of time into the future. Okay. So let's talk about what works. There are basically only two display interface standards that works if you want to drive 4K content. Just two. The first is DisplayPort. Now, DisplayPort from day one has supported 4K resolution. It has the bandwidth. It's actually a better connector than HDMI, in my opinion, because it locks. Okay. The problem with DisplayPort, of course, is that if you go out there and buy any TV or commercial digital signage screen or display, I can tell you that some of them have DisplayPort. Some of them, maybe a minority of them. Okay, all of them have HDMI. I cannot find one display today that does not have HDMI. It almost doesn't exist. Now, which means that you may or may not have DisplayPort available to you, but you will always have HDMI available to you. With HDMI, though, you want to be sure that it's HDMI 2.0, and it has to be HDMI 2.0 for the display, HDMI 2.0 for the player. Okay, both have to be HDMI 2.0 compliant. Then and only then can you drive 4K resolutions at the full refresh rate. This is something that only HDMI 2.0 can do. And HDMI 2.0 really hasn't been available on the display end and on the computer end until, to be honest, theoretically about 2 years ago, but realistically in terms of products on the market, about a year ago, maybe less. One of the things that I also want to mention is that we have to be realistic about what today's hardware can do and what kind of content they can drive, and and what you would like it to do. So just to overgeneralize, if you will, in general, if you're using a PC-based digital signage player, driving one 4K screen can be done confidently. I mean, unless you have something with a low power processor like an Atom or like an AMD G series or something of that sort, if you have a full performance PC, generally speaking, you can confidently drive one 4K displays with a great amount of confidence that you have enough performance to do that. Driving multiple 4K screens is doable. For instance, we're going to talk about a product that IBASE has put out, and that's not the only product out there or the only choice, only solutions out there, but it's an example. It is a product that has the ability to drive multiple 4K screens. In fact, it can drive 3 at the same time. But if you're thinking about driving multiple 4K screens from a single player, from a single PC-based player, that particular content better be relatively unchallenging or relatively static. Let me give you a few examples. If you are driving content that is, for example, a high-definition map of a theme park, right, with great details and whatnot, that's a map. Very little things move on there, or maybe there's a little bit of a movement, there's a little bit of a smoke rising from, one or two birds flying across the landscape and things like that. That's okay. If you are driving, let's say, 3 large airport arrival departure schedule signs where you have all the flights coming in and going out displayed on 3 screens, 3 very large screens in very high detail, you can do that because those things basically don't move. I mean, you have one update maybe every couple of minutes, right? So that's perfectly fine. But if you're planning on, for instance, driving one single video content across 3 screens, I think you will hit performance bottlenecks based on today's PCs. And that's something that we can fix until some point of time in the future. Now, PCs being used in digital signage, computers being used in digital signage, offer one of the fundamental advantages is that it allows you to deliver content to multiple locations remotely and manage the delivery of those contents remotely. Okay, so it will be able to, PCs today have great facilities, especially some of the features that we'll talk about. I think our co-presenter from Intel will talk about later, that helps you identify, issues with players already deployed and fix those issues remotely. I think that's a great facility. Well, what PC-based digital signage players cannot do today with regards to 4K is that one of the things, I mean, in addition to not being able to drive multiple, 3 or 4 or 2 4K screens successfully and with great smoothness, one of the things that it cannot do is fix the fundamental challenges of delivering these very, very large files over the network. So all 4K content should be cached locally on those players and played back. You should never stream 4K content, because if you stream 4K content, the amount of bandwidth that you need across your entire network to reach the tens or hundreds of thousands of players out there will absolutely kill you. You cannot do that, okay, effectively. Now, the other thing that 4K hardware cannot do is basically turn your low definition content into high definition content. So if your content is actually originally recorded and produced in 1080p or 720p or some lower resolution, putting it on a 4K screen through a 4K capable player will just upscale that content. It will not make it any better. It will not make it any crisper. In general, I think you're just wasting your money on the hardware, except maybe you want to prepare that installation, that deployment for future content that may become available that will fully utilize its capabilities. Now, another thing is that we want to be totally honest about this. And that is that PC performance matters. All computers are not created equal. Okay, so if you plan on doing 4K content, you need the same kind of performance that is equivalent to a player that can successfully drive 4 1080p screens. You want a fast processor, which means, generally speaking, you want a desktop processor because they go to higher clock speeds. They run their memory at higher speeds. And you want a lot of memory bandwidth. You want the fastest memory bandwidth that you can get. And memory bandwidth really is one of the biggest bottlenecks in digital signage. It really is, I think, in my opinion, a bigger bottleneck than processor performance or anything else. And we can just do some simple math. Driving a 4K screen, that's 8.3 megapixels on the screen. Each of those pixels, it represents 24 bits of color data. We're doing that 60 times a second, all right? That is about 1.5 gigabytes a second. 1.5 gigabytes a second. Just the video, stream going out through that HDMI 2.0 DisplayPort connector. Just that, nothing else. We're not even talking about decoding the content, doing an overlay, performing any effects, doing any processing, or doing anything like that. So realistically, you need a factor more in terms of memory bandwidth just to cope with the read and write cycles that will happen when you drive 4K content through a PC. So memory bandwidth is very, very important. Now, over the last year or so, a good amount, I would say, of landscape changes have made making a 4K deployment much more available and much more attainable to people who are interested in doing that. Now, I'll name the things that kind of make a big difference in the landscape. One of which is HDMI 2.0 finally showed up. Okay, if you go back about 2 years or a year and a half, or even 1 year, and you try to buy a PC with an HDMI 2.0 connector, good luck. Okay, you're not going to find one. Another thing is the PC industry, the computing industry, the electronics industry has been stuck with DDR3 for many, many years. In fact, I think we've been in DDR3 for, what, 7 or 8 years, I think. Finally, we made the leap to DDR4 this year. Actually towards Christmas of last year, but finally we're on DDR4, and that brings the additional bandwidth that we so crave for digital signage. And finally, we got the kind of performance that we need on CPUs that do not dissipate 150 watts or some ridiculous amount of heat. We can now do it with processors that generate 65 watts, 45 watts, 35 watts, some reasonable amount of power consumption and heat production. 4K screens used to cost $10,000, $20,000. Today they don't. Today you can go to a consumer electronics store and buy a 4K TV for less than $1,000. In fact, if you look really hard, I think you can find one for less than $700 if you try really, really hard. And they probably are not very good ones, but it is, technically speaking, 4K. You can get commercial displays, displays that are designed to be put in a public place and be run 24/7, okay, for less than $4,000. So it's very available and relatively affordable now. It used to be that 4K content is also non-existent. But today, again, recording devices, digital cameras with video capabilities, or video cameras and production, equipment designed specifically to deal with 4K is also now commonplace. So through whoever is producing your content, getting 4K content produced and be made available is now no longer a huge challenge like it was before. A few years ago. A few years ago, only the Hollywood guys with their fancy cameras producing multi-million-dollar movies actually shoot in 4K. Now, well, I have a Sony A7 R2 camera, and that shoots in 4K. So anyway. So there are a few things to watch for. Okay, you really want the fastest memory bandwidth that you can get, because memory bandwidth is crucial, which means that when you're shopping for a digital signage player, of any brand from any manufacturer, you really want to make sure that it's DDR4 and you get it in dual channel, because that's how you get to 34 gigabytes a second, which is what you can get today. And when you get that player, make sure you install your memory in identical pairs, because if you don't do that, it's not going to be operating in dual channel mode for the most part, and you're not going to get your memory bandwidth. It's like cutting your memory bandwidth in half, and that's, generally speaking, a horrible waste of money and not a very good idea. Another thing is that given that this is digital signage, I believe that you should seriously look into what your remote management needs are. You may need Intel's AMT, or advanced management technology, to facilitate remote management. You can also use IPMI or Dash, but IPMI might be a little bit of an overkill for digital signage. Dash has some availability issues today on today's marketscape. So anyway, those are the things that you may want to consider. If you want that connection to be secure, so nobody hacks into your network and put up inappropriate things or mess with your ability to deliver content, you might want to consider solutions with a trusted platform module, so that the communications between your devices can be authenticated and encrypted. Now, if you are dealing with an installation that is not sitting at an indoor or static location, if it is going to be in a remote location, like on the side of a freeway or someplace which you may not have a network capability, excuse me, where you may not have network connections readily available, or if it's on a mobile location, like on a bus or on a train or something like that, you may need to have a solution that has mobile networking. In other words, networking capabilities that are delivered through the 3G or 4G or LTE, mobile phone network. And you may need a GPS receiver to know where you are, because a lot of these installations, a lot of these deployments involve a moving vehicle, a train or a bus, or even a taxi cab or whatever it is. And you may need to be able to show different content depending on where you are. If you just arrived at the airport terminal, you want to show, let's say, the arrival schedules and things like that. If you just arrived at the parking garage, you might want to show a different set of information on the screen. So you may want to look at having those facilities available on your player, at least as an option. Now, finally, I want to talk about something called Electronic Display ID, or EDID. This is one of the most common failure points of any digital signage deployment, whether it's 4K or not. You'll be surprised. About half of the problems that I heard of in the field has something related to EDID or is directly caused by EDID. And that is that when you connect a screen to a computer or a player or any device that drives that screen, what happens is that there's a handshaking that happens. The screen says that I'm connected, I'm live, I'm on, and these are the resolutions that I support. Okay, the controller then, utilizing this information, sends out the right picture. Now, I think everybody has seen that if you have a laptop and you walk into a conference room and you plug in that cable into your laptop to drive that projector, the first thing that happens is that Windows or OS X or whatever OS you're operating on will throw up a little window asking you to configure your displays, whether you want to clone the screens, whether you want to have an extended desktop, and what those resolutions are, or whatever that is. Unfortunately, let's say you have a digital menu board at a fast food chain. What's going to happen? What do you think is going to happen if somebody accidentally unplugged one of those screens? Now, ideally, one screen will go black, and the remaining 3 screens or 2 screens or 1 screen or whatever it is will continue displaying that menu. And then when somebody plugs that cable back in, the screen comes back on, and we're all good, right? But that's not what happens. When you unplug one screen, it's like unplugging the projector in your conference room. Windows or OS X or whatever, your OS is going to throw out a dialog box telling you to reconfigure your screen. When you plug the screen back in, same thing happens. Now, that is a convenience when you walk into a conference room. That is a total failure in digital signage. So, and this happens because the interface, like HDMI, for instance, have this facility to detect that the screen is connected, right, and allow this handshaking to happen. We want to hide that. We want to hide that from the digital signage players. Okay. So what we normally do, you can do one of 2 things. Okay. You can use what is called an EDID dongle, like that black little thing that looks like a stick of gum on screen, that goes between your HDMI port and your cable. So as long as that dongle stays in place, a screen can be powered on or powered off. It can be unplugged. Somebody can accidentally kick the cable, or somebody could literally fry or break that screen, and the player would know about it. It would think, as long as that dongle is connected, it would think that the dongle is the screen, and they would think that screen is connected. So you won't have those dollar boxes popped up or anything like that. Sometimes, at the end of the day, when everything is powered down, and the next morning when things are powered up, some displays will power up more slowly, will not send the EDID information that will then cause the player to usually think that one screen is missing and, again, pop up some dialog box asking you to reconfigure screens. If you have dongles in place, you don't have to worry about that, because those dongles will always report a screen being on, a screen being present, and will report the same resolution, so you don't get that failure. Half the failures in the field happens because of something related to this handshaking. Okay. There's also a better solution. Some of the professional hardware, by that I mean industrial grade digital signage players, and not the kind of PC you get at a local electronics store has something, okay, called built-in EDID emulation or display continuity. They go by different names, but those are the terms that you want to look for, because if they have that, it means that you don't even need those dongles, because the logic board of that player already has that EDID dongle built into it. So you don't have to worry about cables being connected. You don't have to worry about having 3, 4, 5, or however many dongles sticking out the back. And the dongle will protect you from anything that happens on the screen or with the cable. It will not protect you if you accidentally unplug the dongle, or the dongle itself comes loose, right? But if you have it built in, that's not something that you worry about. And this failure mode doesn't go away with 4K or any other kind of resolution. This failure mode is very common, and this failure mode is something that you really should pay attention to. And with 4K, it's still there, and we have to deal with it. Okay. Now, next, I'm going to give an example of what I personally believe is a good 4K digital signage player solution. This is an IBASE product, full disclosure here, but it's the only example that I can give, because I can't be talking about somebody else's product, good or bad, right? So this is an example that I can give, and I honestly believe that this is a great product. So this year we put out something called SI613. This is based on the latest Intel, Skylake architecture, brand new digital signage player, rugged, embedded. It's not your home PC. This is designed to drive digital signage 24/7, and it has, I believe, all the features that you're looking for in a 4K device. First of all, it's got 3 HDMI 2.0 ports. Now he has 3 HDMI 2.0 ports because we believe that this is a more convenient standard to use compared to DisplayPort. Again, as I said before, every screen that you buy will have HDMI. Okay, some of them may have DisplayPort, and in fact, the last time I checked, only somewhere between 15 to 30% of the screens out there have DisplayPort. So and all 3 ports are HDMI 2.0, meaning that you can drive 1, 2, or 3 4K displays with reasonable expectations for performance, of course, but you can do that. It also has built into it EDID emulation. So you don't have to worry about the whole EDID issues. If you disconnect a cable, if a display gets powered off, if somebody broke one of the displays, the digital signage software will know about it, and the other displays will continue as if nothing has happened. This has, if you are looking at remote management, this has IAMT version 11. It has a trusted platform module. It has VPro, and it has Watchdog. Everything that you need on a hardware level to do remote management successfully, and to whatever extent you plan on doing so. It has the fastest memory bandwidth that can currently be had on a PC platform, 2133 DDR4, which is 34 gigabytes a second in dual channel mode. Okay, there is no moving parts in terms of storage on this unit. It's an SSD device, so it's all solid state. Okay, if you need Wi-Fi or Bluetooth, 4G, LTE, or TV tuner options, there are Mini PCI Express and M.2 slots within this device that allows you to add those capabilities. It has Gigabit Ethernet built in, obviously. It also has something that we pride ourselves over, that we put into most of our digital signage products, and that is that it has segregated flow ventilation. Now, this player, to maximize performance, runs off of a desktop processor. It doesn't run off of a mobile processor. It runs off of a desktop processor for maximum performance. But that also means that it puts out a notable amount of heat. It cannot be cooled without a fan. So we put a fan in there, but the entire airflow, as you can see in this picture, goes through a separate channel from the electronics box. The airflow is drawn in to the side of the system. It's completely cordoned off until it's ejected through the heatsink on top of the system, and that airflow doesn't go into the box where your memory is, where your processor is, where dust can be an issue. A cockroach or some insect can crawl up into any place on this system, and it's not going to get and get sucked in. It's not going to go on into where your electronics is, and that helps with long-term reliability. You can mount this directly with 4 screw holes directly to a mounting bracket or directly to a wall or someplace. And there is no plastic part anywhere. This is an aluminum die casting, all metal design, and it's both actively cooled for the main processor and passively cooled for everything else. So I think this is a good solution. I'm not saying it's the only solution out there, but I think this is an example of a player that has all the capabilities, I think, that you want to look out for when looking for a 4K solution. So next, we're going to talk about some of the digital signage deployments that we have done in the past. I'm going to go over this relatively quickly before I hand over my time to our partner here over at Intel, and he will tell you more about the underlying technologies that help make 4K digital signage on a PC platform successful. So I'm going to go over some of the success stories. This is an advertising video wall at for Lancome Cosmetics. Again, multiple displays driven off a single player. Okay, it's powered by a different product of ours, driving a huge number of screens. Now, what that means is that this is the kind of installation. This is not 4K, by the way. This is, well, cumulatively it is, but each one of those screens are not. Right. This is one of those instances whereby if you have a 4K solution, you actually have content that goes to that high of a resolution. And if you have a 4K solution, sometimes you can use fewer screens and have that same definition. This is another example. This is an airport in Denmark, and we have a multiple display installation here. Okay, and this is 9 screens. There are 9 screens going at the full 1080p resolution. Again, this actually has resolution exceeding 4K, and they're driving content that is in excess of 4K resolutions. And we can do that successfully with today's PC-based solution. Again, a 3x2 video display array, okay, being driven by a PC, and this one is in a shopping mall in Norway. This is actually a linear display, a linear string of displays that is comprised of 5 individual screens. We're using a system that can drive up to 5 screens. Actually, it can drive up to 6 independent screens, but in this case, we're using 5 in a linear arrangement. Again, we're driving actually a little bit more, about 25% more pixels than a single 4K display would, and we have great success with this solution driving similar arrangements. So the performance is definitely there if you make the right decisions and the right choices in regards to hardware and your solution. Now, this is a fast food chain, and this is again the typical digital menu board type application. Again, we have the same player, which is capable of driving 6, but we're using it to drive 3 screens. And again, remember I talked about EDID. Now, this is one of those installations whereby if you don't have EDID emulation, I can almost guarantee you that sometime in the next 1 to 2 years, something's going to happen there, and you're going to have a very embarrassing moment on screen that you have to tackle with. So again, this is one of those things where built-in EDID emulation, or at the very minimum using an EDID dongle, is crucial. Now, finally, this is a supermarket in the United States. Again, same thing. We're driving, in this case, using a very compact player, the SI304, which has 4 HDMI outputs, and in this case, we're driving 3, in a bar arrangement. Again, a different player. In this case, we don't have to worry about the EDID problems or with EDID dongles because we have built-in EDID emulation on this particular device. So I think those are some of the case stories illustrating some of the points that I made earlier. And at this point, I'd like to turn the mic over to Nareen from Intel, and he will tell you about some of the underlying technologies from Intel that make all these things possible, obtainable, and easy. Nareen?
Thank you, Dwight. That was a great presentation, and good morning, good afternoon, everyone. This is Nareen Kumar with Intel. I drive digital signage for the Americas at Intel. I'm very delighted to be here and just sharing, I want to share broadly about, just about what we hear, retailers, brands, what are they thinking. That's one aspect. I also want to talk about the market sizing as well, what we see from IoT, like Internet of Things in digital signage market. Just paint that picture. And then, we're talking about experience. What's Intel doing to drive a rich experience? I want to spend some time. These are all the areas that I really wanted to touch upon. And please do, I know if you have any questions, comments, please make sure that you send them via chat. All right. With that, let me start. I think, experience is everything. If you talk to retailers, brands, they have a very key objective or a very key focus. Their number one job is, how do I attract consumers? And not just attract, engage with the consumers and understand the consumers. That's their number one, if you will, focus or pain point, if you will, across the verticals, retail, entertainment, or hospitality, name it. They want to drive experience as a result to attract, engage, and understand. And the reason behind it is because they want to know consumers, the way consumers think, act, like, dislike, and basically arrive at the decision point. And so hence retailers and brands can accordingly define their product strategy and other operational efficiencies. Right? So from that standpoint, experience is everything. Of course, I'll go more into details, more around experience and how we as Intel, along with ecosystem, drive this rich experience. But switching gears a little bit from a market standpoint, Internet of Things, as you all know, that it's growing. It's a big market out there. It's really about connecting things together. And as a result, when they connected, it's just creating a new business model that the things that were previously not connected, and now they're connected, they start sharing information, very valuable insight. And processing that information and providing great insights, data insights, is the key business model around Internet of Things. And per IDC and other sources like NSR, IoT revenue by 2020 is about $1.4 trillion US dollars, of course, worldwide, and $430 billion for US alone. And digital signage is very much part of Internet of Things. And per the market research, about $20 billion is what we see the digital signage in the U.S. market and above. That's from IDC. And similar sources, by 2020, there will be about 45 million units screen shipment and 15 million units of media players shipment. And media players can be various forms. It could be like a compute stick, as you see on the screen. It could be like an external form factor, like what IBASE just mentioned, or it could even be an OPS-based, like open pluggable standard-based. Media players, again, can be of various forms. Anyway, just wanted to paint this picture. There's a big market out there, and I think Intel and the ecosystem, we're all working hard to go win this market. So we talked about experience, the need for experience from end customer, ordinary brands. They really want to drive rich experience. I believe behind every experience, you need the right compute processing compute. So I'm happy to say that the Intel 14 nanometer 6th generation, which is Skylake, is giving that level of CPU performance. But experience is much more than CPU. It needs rich graphics. It needs rich media. because we're talking about experience which is visual, so we want to drive rich graphics and media. And then interaction. I think we're at a day and age where we're not at a point of using keyboards to enter inputs. We are more touch, feel, and interact, use gestures, and so on. So again, interaction is a key component, and Intel does have technologies to enable that. Connectivity, as you know, is very key as part of overall IoT and as well as digital signage. Content management is another key attribute for driving rich content. It can be Intel's Retail Client Manager or the ecosystem, this broad ecosystem. We want to make sure that it runs best on Intel architecture. Analytics, like I told you, brands and customers care about who's standing in front of the screen. They want to understand the consumers. I think analytics really helps determine those attributes brands care about. And Intel has solutions like Intel AIM Suite or Intel RealSense, plus there are other ecosystem that runs very good on Intel as well. Security is very key. We want to make sure that the digital signs out there are secure, just like Dwight was touching on. And lastly is the remote management. I think remote management is another key, very, very key attribute. End of the day, what you're looking in the screen now, just imagine if that screen were to be dark and it's just powered off. I think it's defeating the purpose of our end customer. It's not giving the ROI they're looking for. So with this technology, remote management, we have the ability to bring the system back up for whatever faults. So we have a capability. I'll talk more later on in the subsequent slides. So just talking about the compute aspect itself, as you heard from Dwight, IBASE is using Intel's Skylake processor or 6th generation Intel Core. Really, it's packed with great performance. It's like the latest processor technology. It's about 10% additional CPU compared to the previous generation. It brings in DDR4 support and great graphics support as well, 30% faster compared to previous. And then, since we are in the visual world, we also support accelerators like hardware media codecs and decodecs, like, HEVC, VP8, VP9, and so on. It's packed into the silicon that we should leverage for the visual communication of visual media. And lastly, security and manageability, of course. The CPU is packed with built-in security capabilities. A few other capabilities, just to touch upon the security, we have, for software protection, we have something called software guard protections, making sure that softwares are programmed in a way that they are not being attacked by rogue softwares and so on. So we have software capability called software guard extensions. It comes with Skylake processor. Memory protections as well. As you know, back in the days you have this memory corruption, pointers pointing at the wrong place. So we have such protections in the silicon. So again, this is more for the developers to keep in mind. So Intel silicon comes with those level of protection, so your software does not crash for whatever reasons. Right? And then I talked about GPUs, hardware accelerator functionalities that just amplifies your overall experience when you use Intel processor. And DDR4 support, I did talk about it. So let me quickly touch a little bit more on the VPro. I think at the end of the day, when you have an Intel-based processor, Core i5, i7 with VPro, you're basically giving that peace of mind to your end customers that, hey, when the systems are down, you can remotely manage. And basically, it's manageable, it's flexible, and it's very secure. And that's what VPro brings to the table. Right? And just double-clicking a little bit more on a very specific technology called Intel Active Management Technology as part of VPro. I think really the premise or the business goal for this technology is we want to ensure that customers have increased uptime. We don't want a sign to be half the time down for BIOS issues or OS crashes or name it, or hard disk. We don't want that. It's defeating the purpose of a digital sign. And as a result, it's also lowering total cost of ownership, right? So this technology called active management technology would really help you. Yes, problems do occur. We can't avoid it, but I think it's important how do you react to the problems when they do occur. And that's where active management technology is coming to rescue. Just to talk a little more about this active management technology, it supports various use cases, and especially someone like an administrator or IT guy would love this. You could remote desktop, you could remotely log into a screen securely and see what's happening on the screen, and this is all done below the hardware. You can also, power on and off the systems remotely. Yes, solutions out there exist that you can power off the device, but there's not a solution that you could power on the device remotely, and that's what this technology brings to the table. And if there's an OS crash, you have the ability to bring the system back up and so on. And of course, there are other alerting capabilities and so on. And lastly, hardware and software inventory, where I talked about lowering your total cost of ownership. And that really implies that, how do I minimize truck rolls, sending technicians on site? It is an expensive proposition. The prices can vary. It could be $150, $250, $2,000. You guys know the pricing, but our goal is how do we minimize that? And you could do that, minimize. And then secondly, there are cases where you truly need to send someone. How do you want to make sure you prepare the technician well ahead of, with the right hardware and software details that they go the first time and fix the problem the very first visit. So AMT gives you those details as well. Anyway, so again, this was a very crash course on the active management technology, if you will. But I'd like to wrap it up. From my standpoint, again, retailers and again, broader end customers name the vehicle, retail, entertainment, transportation, and so on, and brands, of course, their focus is driving rich consumer experience. As a result, they can understand the consumer behavior, right? So we as Intel and the ecosystem, we want to, come up with solutions that are very innovative, secure, and again, meeting that our customers' requirements, right? And then lastly, of course, we understand, we as an Intel, we understand how the end customers act. We are thought leaders in this area. And so why not try Intel-based solutions, such as IBASE solutions, for instance. Again, thank you for your time. I'll hand it back to Chris.
Well, thank you, Naren, and thank you, Dwight, for a great presentation today. We're going to turn now to the interactive portion of today's webinar. We've gotten a couple of questions, but we invite those of you who've joined us today to use the chat window on the lower left-hand corner of your screen to submit questions for Dwight and Naren. And we'll go ahead and jump into one of the questions we've gotten so far. And the question is we'll start it with Dwight, and then maybe Naren can chime in as well. Besides hardware, could you point out some use cases that 4K is really a true benefit, especially in cases where it might be better than using 1080p?
Well, I think it comes down to one thing. Very big screens being viewed at a very close distance. That's when you get the most benefit from 4K, right? So if you have a very big screen and people are going to be viewing it from a feet or 2 feet or 3 feet away, that's when you really benefit from the additional resolution. Now, very small screens being viewed at a distance, or big screens viewed at a distance, not so much. If it's going to be something that's being viewed from a large distance away, like if you drive down Las Vegas Boulevard and you see all these LED signs on the side of the casino properties, none of those things are in 4K. And in fact, none of them are in 1080p or even 720. They're actually very low resolution, but they look great because they are being viewed from a large distance away. So it really doesn't matter. So really, it's if you're looking at the screen very close up from a short distance, then the additional resolution can really benefit the content.
And if I may, this is Naren, to chime to what Dwight mentioned. And the reasons why you probably bring someone closer to a screen is that, we're again driving experience that's, touch. you want to interact. There are scenarios where it's all about engaging with consumers, so the closer interaction with big displays and like Dwight mentioned, it brings the consumer closer and getting them engaging.
Excellent. And actually, I was going to ask you, Naren, if you could sort of follow up on that. You talked about the objective of providing rich experiences, and could you guys perhaps expand upon how 4K really creates an even greater, richer experience for customers?
I think we know. I think we did to a certain extent talk about really 4K is basically it's taking up the game to the next level. You want that content, to be media, a video, very, very attractive, and it's like we call it's immersive. When you see that, whatever you're looking at the screen, it just draws you closer. And in my opinion, 4K is giving that, like Dwight was mentioning, that high resolution. It's just making you bring closer. I'll just make it up. If you're looking at a burger on a screen, it will want you to go buy a burger, like just looking at a screen. So such immersive, that just draws you closer. Dwight, anything you'd like to add? Anyway, so back to you, Chris.
Yeah, sure thing, Naren. One of the other things I was going to ask about is this has been sort of a topic of discussion in the digital signage world recently is the development of the overall 4K ecosystem. And so obviously we have media players. How is the rest of the ecosystem developing? I mean, where are we in terms of good sources of 4K content and everything else? I mean, obviously we've got the displays and the media players, but and somebody else just chimed in about content making the experience. Where is can you guys offer some perspective on where the ecosystem is in terms of the availability of 4K content?
Yeah, in fact, just about 2 or 3 weeks back, we got a great article from Digital Signage Today indicating that 4K is actually going in mass production or mass market, right? It's going faster. So that's a great indication that as the experience is getting richer and richer, and 4K is becoming, it's no longer that commodity, if you will, that expensive proposition. It's coming to a point. It's affordable. It's rich. It's driving rich experience. I think the overall ecosystem is getting it that it's time to go. And again, in fact, if you look at Rio Olympics, for instance, it's publicly known that they're driving 8K content, and next Olympics they're driving 8K content. I think yes, there's a niche there. We're talking about 8K, but in general for mass, we're already seeing that 4K is taking basically a flight. Like it's going main scale now.
All right, thank you. And Dwight, did you want to chime in on that at all, or?
No, I think Naren covered it pretty much. I would have.
Okay. Then sort of the last question I had is something where this is something I've talked about with people in the industry as well, is that even if you're not perhaps using 4K content today, having 4K capable media players future-proofs your deployment. So when you do want to upgrade to 4K content, you're not stuck with a media player that can't handle it, and then you have to go out and buy a new player. Can you, Dwight, maybe address that concept a little bit?
Yes, and if you said that 2 years ago or 3 years ago, I would say it makes no sense, because why would you be paying an exorbitant amount of money, like 5-6 times as much money for a capabilities that you're not using currently and may or may not use in the next 2 to 3 years. But today, the marginal cost of getting your deployment 4K ready really isn't. I mean, it is a little bit more expensive than 1080p, but it's not that much more anymore. Again, because screens have gotten much more affordable. 4K hardware, like players and connectivity has become much more available. And so today, we're really looking at maybe somewhere between 20 to 50% more money. So that is then it becomes then it starts to make sense, and I think today it starts to make sense.
Great, thank you. Naren, did you want to add anything to that?
I think Dwight covered it. My only comment is it's not a question of if with 4K, it's a question of when, and I think the when is now.
Great, great. Well, and that's a great note to wrap up on. I'd like to thank all today's participants for attending our call today and for some great questions. And I'd like to thank Dwight and Naren for a great presentation. If you had any questions that did not get answered today, please contact us and let us know if we can reach back out to you. We'll be glad to follow up. And thank you all, and have a great afternoon.
Thank you.